Hi team, we're ready for systems of nonlinear equations. We're going to be dealing with just two variables. Remember, if we have two variables, then we need two equations or inequalities. A system of nonlinear equations is a system where you have at least two equations with at least two variables, but at least one of those equations is not linear. So even though it says a system of nonlinear, one of them can be linear, but they can't both be linear. And we're going to use the methods that we've used before, elimination, also called the addition method, and substitution methods. So let's take a look at example 1. When we're solving linear equations, it's nice to generally label our equations so we know which one we're working with at which time. Since in A, we have squared variables and single variables to the first exponent, linear variables, then it's probably best if we use substitution. It's up to us whether or not we want to solve for x or y, but I would probably solve for the y value in equation B because it has an exponent of 1 and only a -1 coefficient. So let's get that y by itself. We're going to subtract 3x from both sides, so that would give us a -3x plus 10. Divide everybody by that -1, and we get y equals a positive 3x minus 10. So now we have a value for y with x. We were going to substitute into equation A. So remember, equation A is x squared plus y squared equals 100. So we're going to take that binomial that represents y, and we're going to plug it in here for y. So we get x squared plus 3x minus 10 squared equals 100. Go ahead and FOIL and combine like terms. And since we ended up with a quadratic, let's set it equal to 0 and see if we can factor. And this gives us two possible solutions for x. Either the first factor equals 0, which means x would equal 0, or the second factor equals 0, which means x would be 6. So remember, to solve any system of equations, we're looking for points or lines that satisfy both. So if x equals 0 and x equals 6, let's find what their corresponding y's will be. So let's first focus on the fact that x equals 0. We are going to use equation B, which is 3x minus y equals 10. So if we substitute in that x equals 0, we would get 3 times 0 minus y equals 10, which would give us a y of -10. So we get the point 0, -10. Now let's plug in our second x value of x equals 6 into our equation B of 3x minus y equals 10. We could have plugged it into A. It's just B would be easier since it's already linear. So we get 3 times 6 minus y equals 10. 18 minus y equals 10. So that means y equals 8. So we get the point 6, 8. So those are our two solutions, 0, -10, and 6, 8. Now let's take a look at problem B. Again, we have equation A and equation B. The nice thing is both equations have x squareds and y squared, so we can use the elimination method. We can keep A as is and multiply equation B by a -1. So when we add the two equations, we're left with a 3x squared equals 3. Divide by 3, we get x squared equals 1. So we get two possible values for x. We take the square root, we get x equals either a -1 or x equals 1. So let's look at both possible solutions. If we first look at x equals -1, again, we can use equation A or B. It just B seems a little bit more simplified. There's no coefficients. So I would prefer to use B, x squared plus y squared equals 10. So if we plug in a -1 for the x squared, 1 plus y squared equals 10. So y squared equals 9, which again, when we take the square root, we have to consider both the positive and negative square root of 9, which would be plus or minus 3. So this gives us two possible points. We have -1, positive 3, and -1, negative 3. Now we have to do the same thing with the second value of x, which is a positive 1. And you may have already guessed, since we're squaring that x value, whether it was a 1 or a -1, we're going to get the exact same y values. So we know y squared is going to be a 9, so y is going to be a plus or minus 3. So that gives us a +1, positive 3, and a +1, negative 3. So in this case, we ended up with 4 points where these two graphs intersect. Now, depending on the type of equations we have, which gives us particular types of graphs, will dictate how many solutions we might have. For example, in that first block, we have a parabola and a line. We may have no solutions because they don't share any points. One solution, they may just intersect at one point, or two solutions. The same can happen if it was a circle and a line. But as we scroll down, what if we had two circles? They might not intersect at all. They may intersect at only one. They could intersect at 2, 3, or possibly 4, unless they were the exact same circle and they were right on top of each other and they intersect in all possible points. So if you have any questions, please don't hesitate to ask me or come by and see me. Thanks. Bye.